Hi, folks. We are going to be working on multiplication using word problems for this week's new topic. So, there are going to be two ways that you can solve these problems. The first is by using a variable. And a variable is a fancy way of using a letter to mark something that is unknown. So let's talk about the things uh, that we know based on this problem. So it says Tom is saving $50 each week. Okay, so we know we're going to be using this 50 somewhere. If he saves for 8 weeks, how much will he have? Okay, so we have at this level, you're going to mostly be saying take one number and another number, multiply it together to get your answer, right? So number A, number B, and then the answer. So we don't know what the answer is. We don't know how much he'll save. So let's use a letter to represent how much he saves. And I'm going to use the letter S for save, right? So S equals how much he's going to save. Now, how much is he saving? He's saving $50, right? And the next thing is, how long is he saving for? He's going to save for 8 weeks. And now we have our entire, what is it? We have our entire equation here. And now we can solve it. 50 times 8 is 400. If you don't know how I got that, I can show you over here. Erase this really fast. If I have 50 times 8, 0 times 8 is 0, 8 times 5 is 40, right? And that gives us our 400. That's one way you can do it. Another way that we can do it is by using a bar diagram. Okay, so you're going to make one bar, right? Because your total is going to be what you get out of this bar, right? And so let's find a way to label this bar. So he's saving money every week, right? So that's the, what is it? So we can section this off based on the amount of weeks he's saving. So let's go ahead and say that this equals the weeks he's saving. So that means in this bar, we need to separate it into 8 different weeks because it says here that he saves for 8 weeks. So we got 1, 2, 3, 4, 5, 6, 7, 8. And you want to try your best to keep all of these even as possible because the number that goes into each of these are going to be is going to be the same because when you multiply, you're going to be multiplying and repeating that. Multiplying is repeated addition, so you're going to be repeating that same number over and over and over again. So it kind of helps visually if they're the same, are roughly the same size. So over the course of 8 weeks, he's going to be saving money. How much is he going to save each week? Tells us $50. So we can put 50 into each one of these boxes that we have here. Okay, so we got 50. Now, all you have to do is add up the information, add up the numbers here. 50, 100, 150, 200, 250, 300, 350, 400. So we know that after 8 weeks, he's going to have $400. And as you can see, both of these problems, both of these solutions to the problem, the setup was different, but it took us to the same location. And that's my goal for you in math. I don't want you to always have to use my way. I want you to find the way that is the most comfortable for you and the most convenient for you. If you like drawing pictures, here's an option for you. If you prefer doing things algebraically, you can use option 1. Okay, so I'm going to put up another problem here. Bear with me, give me just one moment, and I will set up the problem for you. Okay, I'm going to write the problem. And then when I write the problem, I'm going to challenge you to pause and try to figure it out on your own. If you can't, just get as far as you can, okay? Just put your best foot forward, and then we can talk about what were the hangups or the struggles that you had during small group later today. So it says, Brad lives 12 times as far from the beach and this is on page 145, question 4 from your book, just in case this writing is too small and you want to see it for yourself. From the ocean, from the ocean as Ginny. Okay. If Ginny lives 48 miles from the beach, how many miles away does Brad live? Brad live. Make sure I got everything. Yes, okay, so we got everything here. So Brad lives 12 times as far from the ocean as Ginny. If Ginny lives 48 miles from the beach, how many miles away does Brad live? Okay, so here is your question. I want you to pause and I want you to give this a shot on your own. Okay, so I know you all paused. I know you all gave it a shot. Now let's break it down. What I'm going to do to give myself some space and so that you can see everything, I'm going to erase the question. But remember, the question is on page 145, number 4 in your book, in your volume 1. So our question was, Brad lives 12 miles as far away from the ocean as Ginny. If Ginny lives 48 miles from the ocean, how many miles from the ocean does Brad live? Okay, so we know that we want to know how far away he lives. So let's use L. Something is going to equal L. This is where Brad lives. And so we need number A times number B. So our first number, Brad lives 12 times. So 12. And that word times, that is a key word. When you hear that, you know, or you read that, you know, I am going to be multiplying. Okay? So we have 12 times, right? As far away from the ocean as Ginny. And Ginny lives 48 miles from the ocean. So now our problem is set up, and then we can, we can just multiply using standard algorithm to get our answer. 48 times 12, 16, carry the 1, 8, 9, we got 96 there, add a 0 because we're multiplying by 10 here, 8, 4, add it all together, 576. Okay, that's one way that you can do it. An additional way is you can set up that bar graph. Remember the bar graph we were talking about earlier? So make your bar. And when it comes to trying to figure out how to section your bar graph, at this stage, again, it's a little deeper than this, but for now, choose the smaller number of the two that you're given. If you're given two numbers, choose the smaller number and break your bar up into that many equal groups. So we have two numbers. We have 12 and 48. The 12 represents how many times further away from the beach how many times you have to multiply Ginny's distance from the beach. And the 48 represents Ginny's distance, right? So we could, because there's something called the commutative property of multiplication, we could break this up into 48 groups, this bar graph, and then put 12 into each of those. But that would get very tedious and very boring, right? And it increases the chance of making a mistake because we have to do that same thing 48 times. So let's break this up into 12 groups because 12 is a lot smaller than 48. So remember, you want to get them as equal as possible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I just eyeball it, but just if you want to use a ruler, that's obviously something you can do. Now that we have our group of 12, right? This is how many times that Brad lives further away than Jenny does. Now we're going to take this number for Jenny and we're going to plug it into each of these available boxes. And then from here, you would add them all together. Okay? You can add them all together. You can go, another thing you can do, because this is kind of an awkward number, 48, right? It doesn't add that evenly. We know that a close friendly number is 50. So I could go 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, right? But I didn't. It's not supposed to be 50. It's supposed to be 48. So I added two extra every time. So 2 times 12 would be 24. I can subtract 24 here. So if this is confusing, don't worry about it. You don't have to do it this way. But this is just another option. Got 10, 9, 10, 6, 7, 5, 76. So we get the same answer no matter which way we go about it. If you want, you can physically add 48 plus 48. Okay, I'm at 96. Add another 48, add another 48, and so on and so forth until they're all gone. So it's not about being the fastest. It's not about making this a race or a sprint to the finish line. It's about finding which type of problem solving gets you to your answer consistently. That's what's most important is consistency. So I hope this helps. Good luck, folks, and I will be seeing you in small group in about 30 minutes to an hour or so. Oh, wait, sorry. Yeah, we're going to be doing small group a little bit different today, but I'll still be seeing you in about 30 minutes. So good luck, and I'll see you then.